The hardened
Not
copper
to the
jacket.
That's right. The specifications for those bullets were that it was number 0 soft lead, unhardened lead, that was at least 99.85% lead. So obviously no room for added antimony in them.
One of the most serious questions facing the panel is the identification of the pristine bullet with the fragment taken from Governor Conley, the wrist area. Now, I realize the importance of your conclusion that the fragments removed during the surgery from Governor Conley's wrist were from the pristine bullet, and I realize the difficulty of saying, you know, you're absolutely certain to the exclusion of all other possibilities. But I'm wondering if you could tell us, if you could go any further than you have in terms of certainty of the comparison of those two tests.
I don't think that I can, in the sense of putting a % probability or something like that. All I can say is that those two specimens, 399 and 842, agree so closely in their antimony concentrations and their silver concentrations that I could not distinguish one from the other.
So it is
whereas I can clearly distinguish those two from the other three. They are different. They're still Mannlicher Carcanos, but they represent a different Mannlicher Carcano bullet.
And so it is your testimony that it is very unlikely that these were fragments from two different bullets.
It would be extremely unlikely. You can imagine that certainly there are some Mannlicher Carcanos that are the same, that one bullet could be one and one bullet could just happen to be the same composition, and it could be the one that fractured the wrist, for example, but it's very, very unlikely.
But the scientific term that you use is extremely unlikely, is that correct?
Extremely unlikely or very improbable, however you prefer.
To your knowledge, has any other scientist to date linked the so-called pristine bullet to the injuries?
Not that I'm aware of, no.
Now, equally important as your conclusions concerning Governor Conley's wrist injuries and the pristine bullet is the second conclusion you make, and that is that there is no evidence of a third, fourth, or fifth bullet represented in any of the fragments that you tested.
That's correct.
And therefore, it is highly likely, is that the term you used, Mr. Wolf, that all fragments tested match up with two bullets and two bullets only?
Yes, the other three that we've been referring to, one, it was the fragments recovered from President Kennedy's brain, and then two different groups of particles found on the floor of the limousine. Those three specimens are indistinguishable from one another, but markedly different from the 399 and 842. So there's only evidence of two different bullets.
I understand that the Warren Commission did emission spectrography tests on many of the same items that you have now tested with neutron activation analysis. How does the neutron activation analysis process, just in brief layman's terms, differ, and what are the advantages or disadvantages of the two methods of testing?
Well, they have some similarities and they have some differences. They're both methods of elemental analysis. They will both detect down into what we call the trace element range, approaching parts per million, let's say, but they will both detect a number of elements more or less simultaneously in the specimens. Now, where they differ is that for most elements, at least, we can detect much lower concentrations with activation. In other words, activation analysis is more sensitive. What is perhaps even more important, though, is that the activation analysis, when it measures something, measures it very quantitatively. Emission spectrography does not. I have all of the FBI raw data from those measurements, and they list things like magnesium, a trace, chromium, a very slight trace, and things like that, no numbers. So you can't make any kind of quantitative comparisons by looking at numbers of that sort. And the remaining thing is that the emission spectrographic method is destructive. You normally would like to have about 10 milligrams of sample, which isn't a great deal, but that 10 milligrams is totally consumed. It's vaporized and it's gone. Whereas the way we do bullet lead samples, at least, and many other kinds by activation analysis, it's non-destructive. These same samples I analyzed, if somebody didn't agree with the numbers, they can come back and do them all over again on those same specimens.
Your results then could be verified by another specialist.
All of the samples that I activated and analyzed were then all turned right back over to the archives, and they're right back there.
Dr. Guinn, this is not meant to be an embarrassing question, but I think I must ask. It, Mr. Chairman. A recent article in New Times magazine stated that you had worked for the Warren Commission, and therefore your conclusions for this committee would be implicitly biased. Did you ever work for the Warren Commission or work for the FBI in connection with the analysis of these evidence samples?
Neither one. I think Mr. Wolf called my attention to the existence of this article, which I haven't seen, and I don't know where they got their misinformation, but I never did anything for the Warren Commission, and I've never done any. I know people in the FBI and all that, but I've never done any work for them.
All right. But it is correct, isn't it, that the Warren Commission had the FBI perform neutron activation analysis in 1964?
Yes.
How did you find this out?
Well, it was rather interesting because both Dr. John Nichols and I felt that activation analysis of the bullet lead specimens in the President Kennedy case should be done. And he in particular was trying to persuade J. Edgar Hoover first and later Clarence Kelly that these things should be done. Made no progress. And then, quite accidentally, in the archives, it turned up a letter from J. Edgar Hoover to J. Lee Rankin in July of '64, stating that indeed the FBI had made activation analysis measurements on these samples, which was totally unknown to us. So therefore, after that, we requested the results, because this little letter didn't give any numerical results. It just said they'd been done and the results were generally inconclusive. And this again took quite some time, and it was only finally under the amended Freedom of Information Act that Dr. Nichols was able to get some 70 pages of raw data copied out of the notebooks, and then I took all of those data and recalculated them from scratch myself.
I want to come back to that data in just a moment, because I think it is very, very important for us to explore that with you. But let me ask, prior to doing that, did you know why the existence of these tests were never divulged until recently?
No, I certainly don't know why. I can just speculate. The letter states that, if I may just read this one last little short sentence in it, this is from J. Edgar Hoover to the Warren Commission. It states, while minor variations in composition were found by this method, these were not considered sufficient to permit positively differentiating among the larger bullet fragments, and thus positively determining from which of the larger bullet fragments any given small lead fragment may have come. And I believe probably that the FBI and the Warren Commission both felt that this didn't prove anything in their opinion, and therefore didn't need to be noted. Since we had been asking them for quite some time to do this, we rather thought it would have been nice if they had told us, but instead of our finding out accidentally.
Mr. Chairman, I'd like the record to show that the witness, Dr. Guinn, was reading the last paragraph of a letter from J. Edgar Hoover to J. Lee Rankin, the General Counsel of the President's Commission, the so-called Warren Commission, dated July 8, 1964, and delivered by courier service. I would ask that the entire letter be made a part of this exhibit as JFK Exhibit 332.
Without objection, it may be entered into the record at this point.
May I comment? I will give you this, but it does have stamped on it, which of course wasn't originally John Nichols' stamp when he received it, November of 1973. and he also wrote in himself one little handwritten line. Those were not in the original, but otherwise it's a copy of the original letter.
So, for the record then, the handwritten notation between paragraphs 2 and 3, which read, "He did not examine the copper zinc jackets and fragments," are written by Professor John Nichols and were not a part of the original letter when he received it?
I guess that was John Nichols' little note from him to me that he put in there.
Now, with regard to that important paragraph that says that these are inconclusive, I would like now to ask you, Dr. Guinn, if you could tell us what your findings were when you looked at the same 70 pages of raw data. And prior to that, are you aware or do you know who and how this neutron activation analysis was done, and whether this was a common practice of the FBI or just how this came about?
Yes, I have subsequently found out most of the details of it. When it was decided in May of, when the work was actually done in May of 1964, at that time the FBI laboratory had not done any activation analysis work to my knowledge. But in the same elemental analysis group where it would normally fall, they asked Mr. Jack Gallagher, John F. Gallagher of their staff, whom I know, to take these bullet lead specimens down to the Oak Ridge National Laboratory.
To where?
The Oak Ridge National Laboratory in Oak Ridge, Tennessee, where they have all the nuclear facilities and so on, quite good, and do a lot of activation analysis, although not connected with crime investigation, but for other purposes. He took the samples down there. Two of the people down there who were highly conversant in activation analysis, but not in forensic work, and Mr. Gallagher, who was highly conversant in forensic work, but not in activation analysis, they sort of worked together. He actually did all of the measurements, but with the two Oak Ridge people sort of showing him how to do it and how to calculate, etc., since this was really his first experience in this field.
Are you saying this was the first neutron activation analysis by the FBI?
To my knowledge, it is, yes.
This is the first that they had ever done?
2 years later, in 1966, they set up a regular activation analysis group in the FBI laboratory, which, of course, still operates. But at that time, it was their first contact with it. At any rate, Jack Gallagher, in a period of some days there, did go ahead and analyze the samples, and he calculated the results, and he got a lot of numbers. When I obtained all of these data and so on and went through the calculations, my initial reaction was pretty much the same as theirs or his.
That is, that it was inconclusive?
The numbers appeared to bounce everywhere. Any one sample just didn't seem to be consistent. I just pick an example here. One particular specimen, one time they measured it, it was 977 parts per million antimony. Another time they measured it was only 676. And the numbers just bounced around. They measured each sample a number of times under somewhat different conditions. And it shouldn't make any difference. You should get essentially the same number every time with maybe just different plus or minus uncertainties. But my initial reaction was exactly the same. I just went through all of the stuff quickly, and I initially could not make any sense of it. I concluded they had done careful work in general, but it somehow didn't make sense. Then I did my own analyses here and found very definitely that the samples fell into the two groups, two bullets. So then I asked myself, as far as I know, even though they had more antiquated equipment at that time, these analyses were done well, why can't you get the same results out of their data? And I went back through a second time, and in a very detailed way, and I tried a little bit different approach. And I think I figured out finally what was wrong with their original work, which they were not aware of, and I wasn't initially either. And if you take the numbers that they obtained on the whole group of samples and you only look at them under one set of measurement conditions, you don't look at all the conditions for the moment, just look at one set of conditions, lo and behold, it's exactly the same result. The 399 in every case.
The same result as what?
As what I find.
As what you find by your present
399 matches 842 in each of their 4 sets of conditions that they tried, and the other 3 specimens match one another and are different from the other 2 every time. But if you look at all the numbers at once, everything is varying so much you don't get the picture at all. But once you sort them out this way, then the same result comes as what I obtained. A little fuzzier picture because the detector didn't have that sharp resolution and all that, but of course hindsight is much better than before. I didn't get this out of their data either until after I had my own data. But in a sense it's confirming.
Are you testifying then, Dr. Guinn, that that a more accurate reading of the 1964 neutron activation analysis would have led equally prepared scientists, equally trained scientists, to the conclusion that there were, in fact, fragments from only 2 bullets that were tested?
Yes, the data were there, but they were not interpreted as far as they could be taken.
Using the charts that you provided the committee, and they've previously been admitted into evidence, would you just briefly summarize for me how the readings of your equipment might be more accurate, more specific than those of the FBI? Let me see if I can understand this as a layman. As I understand the process, what you do is you take a particle of something and you put it in some kind of a little
just a container,
and you put that inside the nuclear reactor, and you bombard it with thousands or trillions or whatever you measure neutrons with.
Yes.
And then you remove it from the machine, and in some time frame thereafter, the nuclei that have been created, the isotopes that have been created by the link up of the neutron, the extra neutrons that you bombarded it with, and some parts of the atom or the nuclei, then it is the escape of that recently united unit, or whatever you call it. It is the escape of the energy, the gamma ray, that you're measuring through a certain time frame. Am I roughly correct?
Yes, each nucleus, each radioactive nucleus that undergoes disintegration, which it just decides on its own to do spontaneously, it emits, in the typical case, it emits a beta particle of some energy, which turns out not to be very useful to measure for detailed reasons, but it also usually emits 1 or sometimes 2 or 3 different gamma rays. That means they're gamma rays of different energy. Those we can measure much more easily and exactly. And so those are the ones we look for. Now, one nucleus just gives one little gamma ray. It just gives, at best, it would give 1 count on that counter. So what we're looking at, of course, are thousands or millions of these disintegrating, and we accumulate the results there. But the detector is capable of distinguishing between gamma rays of different energies, and they show up in our spectra as peaks like that. Whether you're looking for it or not, for example, if somebody gave me a sample and I didn't know it had any antimony in it, if I activated it and looked at it under either of those conditions and saw that peak at 564 keV, I would know that the sample had antimony.
The antimony peak will always come at the same part of the spectrum, is that correct?
That's right. That's the characteristic, yes.
And therefore, without any knowledge of what's in it, if you see a peak in that frame of numbers, it has to be antimony,
That's
is
right.
that right? And then the height of the peak indicates the quantity?
It's proportional to it, yes. We usually measure the area instead of the height, but because the peaks aren't quite symmetrical. But you're right.
Now, you've said this whole process that you go through does not destroy the material. Is that correct?
That's correct.
Now, then did you test the same particles that the FBI tested in 1964?
Well, it turns out I did not, for reasons I don't know, because as they did the analysis, they did not destroy the samples either. And that means that particular little pieces that they put in, I could have just as well have done all over again. But the pieces that were brought out from the archives, which reportedly, according to Mr. Gear, were the only bullet lead fragments still present in the archives, did not include any of the specific little pieces that the FBI had analyzed. Presumably those are in existence somewhere. I'm sure nobody threw them out, but where they are, I have no idea.
And the 1964 equipment wouldn't have consumed them either, is that correct?
No.
What was the state of the knowledge at that time in terms of handling radioactive materials? Would there have been any prospect that someone not adequately informed, such as the FBI or the law enforcement people, would have been a little leery about keeping radioactive materials in their files?
I wouldn't think so. I mean, I'm sure by that time they at least had learned enough about the safety aspects. That the size of samples we're dealing with here and the amount of radioactivity is such that they're perfectly harmless, and what activity there is soon decays out.
And so finally, it is your conclusion that despite what Mr. Hoover said to Mr. Rankin, that the FBI data is not really inconclusive, though it appeared to be so to you initially.
That's right. Their data really were fundamentally better than they thought.
The reason I raise that issue, Dr. Guinn, is this. As I understand the critical literature, it falls into two categories with regard to this question. Earlier on, the critics said that the Warren Commission was afraid to do the neutron activation analysis because if they did it, it would show something other than the single bullet theory, and that thereby it would undermine the entire Warren Commission findings. And the charge was made in several places in the literature, and I have several examples here to that extent, that the reason for not doing the neutron activation analysis at that time was the fear on the part of the Bureau that it would show something other than a single bullet theory. That is, the scrapings from Connolly's wrist and the pristine bullet sample would turn out to be two different bullets. Yes. In post-1973 literature, after the Freedom of Information Act episode to which you refer, the critics have said that it was done with results, and since the results were inconclusive, it did not prove that they were from the same bullet, and therefore the publication or the publishing of the results were suppressed because it did not support the single bullet theory. That's why I raised the question specifically about the FBI data and about your analysis or interpretation of that data.
I don't know anything about any of the people's involved motives, but what I do know is that indeed in 1964 the FBI did do the analyses, and according to this letter that we just introduced into evidence, they were not able, did not appear to be able to draw any conclusions from the numbers. Looking at them many years later, I can see why that would be possibly the case, but as I say, with the advantage of these new results to guide me in the right direction of how to statistically treat the data that they'd gotten earlier, lo and behold, they very neatly agree.
Right. Now, is there any evidence in either the FBI interpretation of the test results of 64 or in your own interpretation of the tests for this committee that would support the speculation that there are two different bullets the pristine bullet and the one that hit Connolly's wrist are two separate bullets. Is there any evidence in either report?
No, there's no evidence in either my work or the previous FBI work of that. You cannot distinguish one from the other by the method of analysis as we both independently had turned out carried them out.
Now, going from this conclusion, could the FBI have been able to draw the conclusion of only two bullets being present if someone, anyone there, did not have the kind of expertise in Mannlicher Carcano ammunition that you have testified or that we understand that you possess? Would someone not familiar with that kind of ammunition, could they have drawn the conclusion?
Well, it would have been certainly much more difficult because, as I say, most kinds of ammunition, other kinds that we have looked at over the years, have been so uniform that you literally cannot tell one bullet from another out of the same box of that. Mannlicher Carcano is different. The range is tremendous. For example, out of the same box, one may only have 20 parts per million antimony. The next one you take out of the box might be 1,200 parts per million antimony. And each of these very nicely measurable precisely. So there are real variations there that you don't find. Actually, when Jack Gallagher did these measurements, he did also look at a couple of Mannlicher Carcano just background samples. One of lot 6000, one of lot 6003. But that's all. That's not much of a background to look at. But sure enough, those two, just the two that he looked at, one was about 90, I have the number somewhere here, but not handy. One was like 90 parts per million antimony, and the other one was something like 800 parts per million. So even the two samples that he just happened to pick as background samples immediately showed the same thing that we have much more data about.
So is it your testimony then, or is it your estimate that the FBI's failure to correctly interpret the 1964 data, which is so disturbing to so many people, would the FBI have had the knowledge and the experience in '64 to correctly interpret the results?
Well, it's a little hard to say. I think they might have been able to, but it would be more difficult for them to at that time, since they didn't have background in activation analysis, interpretation of results, and they didn't have any experience with Mannlicher Carcano ammunition either. As for that matter, I didn't either in 1964.
We must, I think, Mr. Chairman, clarify one thing for the record. Dr. Guinn, is your interpretation of the FBI data based on the information you obtained through the FOIA as opposed to any secret or otherwise restricted data that you've obtained through this committee?
No, on the FBI data?
Yes.
No, the data that I have, the raw copies of all the raw data that Jack Gallagher got, were obtained, actually not even by me, they were obtained by Dr. John Nichols from the FBI under the Freedom of Information Act, and then turned over to me. Since he's not an activation analyst, he didn't know what to do with the numbers.
And therefore, any information that has been published either by him or by you it no way falls under any restrictions, is that correct?
No.
One final line of questioning, Dr. Guinn, and then I'll subside. Have you done, as far as your expert knowledge is concerned, have we done all the tests that are possible to ascertain the number of bullets that the fragments came from? Is there anything else that we should do?
One can always think of other analytical methods, et cetera, that might show up some elements that we're not as good at here, et cetera. Or you can, even using activation analysis, you can go to the destructive form of the method, but then you destroy the samples, and I'm sure that's not desirable. I would not recommend any further analytical studies at the present time. I think that the findings that we have are pretty definitive, and most other things that one can think of that you could try on the samples might or might not add some additional information. It's questionable, and most of those methods that are really sensitive would destroy or alter the sample, alter its composition.
And I close with this question then. Since there is no fragment from President Kennedy other than the skull shot, in actual fact, using your scientific method, you cannot shed any light on whether or not the bullet that passed through Governor Connally also passed through the President. Is that a correct statement?
That's correct. These results only show that the .399 pristine bullet, so-called stretcher bullet, matches the fragments in his wrist. They give you no information whatsoever about whether that bullet went through President Kennedy, since it left no track, and for that matter, it doesn't even say that it went through Governor Connally, because through his back, that is, because it left no track there. At least I've never seen any samples from that. It merely says that the stretcher bullet matches the fragments in the wrist, and that indicates that indeed that bullet did fracture the wrist. It unfortunately can't tell you anything else because there were no other bits and pieces along the other wounds.
All right. Then your conclusions are what you just stated as far as the entrance and exit from the throat, and as far as the Connally's wrist and the pristine bullet. And the other conclusion you've referred to today is that the particle taken from President Kennedy's skull matches other fragments that were in the car.
That's right. They match those, and those fragments found in the car do not match the Connally samples.
Then that means that there are two bullets.
There are two bullets. There is no evidence for three.
And there's no evidence for three. Well, thank you, Dr. Guinn. I have no further questions, Mr. Chairman.
Time of the gentleman has expired. Dr. Guinn, I think I just have perhaps maybe one, maybe two questions. Obviously, from your testimony here, it's evident that as an expert in neutron activation analysis, that we're talking about a field in which there are relatively few experts, aren't we?
I wouldn't say so anymore. That might have been true many years back, but every time we have an international conference, we have 500 people there or something like that, all supposedly, and most of them really, experts in some phase or other of activation analysis. It's grown to be a field where there are probably altogether a few thousand people that are knowledgeable in the field.
I see. And if we go back to the period of time we're talking about, 1963, 64, in that period of time, what type of field would there have been then of experts?
Smaller numbers, although even in 1964 we had already had one international conference in the field. We had another one the year after that. So it was obviously already getting to be of some size. But obviously not as many people as there are now.
I see.
It was kind of still considered to be a relatively new method by some people, at least in 1964, although the actual method was first originated in 1937, way back then. But it couldn't be really very useful until the nuclear reactor came along, and that was during the war, and then they weren't immediately available to people. And so it was not until about 1950, you might say, that at least a few places had nuclear reactors and the scintillation detector kind of counting equipment, and then it began to grow at a pretty good clip.
I see. Okay. I have no further questions, and at this time, under the rules of our committee, any witness appearing before the committee, at the conclusion of his testimony is entitled to 5 minutes, and during that 5-minute period he may explain, amplify, or in any way expand upon the testimony he has given to our committee. I would like to extend to you such time at this time, if you so desire.
Thank you, Mr. Chairman. Well, I'll just make one comment that I thought we might have brought out before, but we didn't quite get around to it. If any of you start looking at these detailed numbers, there needs to be a little interpretation there. First of all, some of the elements listed there, in our experience with all kinds of bullet leads, we find that they often show up and they often don't show up, and they don't seem to be characteristic of anything. Some of them are external contamination, so we include them, but I don't think they contribute anything one way or the other. When you start to look at the antimony and the silver values to see if these samples match these and these match these, it should be noted that the plus or minus that is shown after each of those numbers is merely from what we call the counting statistics. We can calculate that. The overall uncertainty of that number on that specific sample is somewhat bigger than that, meaning that if we took that identical little piece and did the same experiment over and over again, we would get, in general, plus or minus. It would vary by a little bit more than that, perhaps even as much as twice as that. It depends on the value. But the plus or minuses, the uncertainties are a little more than that. And then, if you're trying to match this piece and this piece and this piece, which really all came from the same bullet, but you don't know it, you're trying to prove it, you have to take into account how homogeneous is that bullet. Is every piece that you take from a bullet the same? And the answer is no, they're not. They're fairly homogeneous, but there are variations within them. And we have a lot of background data, specifically on Manic or Carcano, in this case, that isn't in the report, but we use that as the backup, which shows that the variation within a bullet is significant. So when you start to compare numbers, it turns out that, for example, on the antimony numbers, roughly speaking, if you take the plus or minus that's shown and multiply it by about 6, that will take care of all of those variabilities within the sample and in the measurement uncertainty is relatively small. It's the variation within that individual bullet is then taken into account. And then you find out that these two samples indeed, for example, the 399 sample, the measured value is 833 parts per million antimony. The 842, it's 797. Well, any grammar school boy will tell you 797 is not the same as 833. But when you consider that the 833 is plus or minus about 50 and the 797 is plus or minus about 50, then you see that you can't distinguish one from the other. They are indistinguishable. But by the same token, the other samples, which are only about roughly 620 plus or minus a smaller amount, in that case about 20 or 30, they very clearly not only match one another, but they're still widely different than this 800 figure. But you must, some of that is explained in the text of the report, but you can't just take the numbers from the table and blindly go ahead. You have to read the fine print as well to see that everything is properly taken into account. But in any event, no, I think the results have come out in a fairly clean-cut fashion. We didn't predict anyway they would come out. They just fell out this way. And as I say, it led me to re-examine the FBI data more than I had done once. And I frankly was very surprised to see that even their data, somewhat fuzzier, et cetera, still fell right into the same picture. So I think that it's been well established. And as I say, fortunately, by using this method, one nice thing about it is you do not destroy the samples. The identical samples are there. They weigh the same. They can be analyzed all over again. All of the radioactivity we induced in them a year ago is long decayed out, so they can be done over again. Other than that, I just want to say that it's been a real pleasure working with the committee and with the staff of the committee, and I thank you very much for inviting me.
I guess you raised one additional question in my mind. Assuming that your data is presented to another expert in your field, can we assume with a reasonable degree of certainty that the expert would come to the same conclusions that you have?
I believe so, yes.
This data?
Yes, yeah. As I say, if you just handed him those, he would initially interpret the plus or minuses as meaning the total uncertainty, and of course then it would say, well, 797 is not the same as 833. But if you notice in there in the text, it's pointed out that that isn't the total uncertainty of a sample. It's larger than that. If he took that into account, he would reach the same conclusions. Yes.
Chair recognizes Counsel Jim Wolf.
Mr. Chairman, for the record, I would like to note that Dr. Guinn's report has been submitted to an independent consultant for review and evaluation, and he completely agreed with the results achieved and reported by Dr. Guinn.
Okay. Dr. Guinn, on behalf of our committee, we thank you very much. You've made a very valuable contribution here today, and we certainly appreciate all that you've expended on our behalf. Thank you. There being no further business to come before the committee today, this committee meeting is adjourned until 9 a.m. Monday morning.
That concludes the third day of public hearings conducted by the House Assassinations Committee on the assassination of President John Kennedy in 1963. The testimony this afternoon came from Vincent Guinn, who is a professor of chemistry at the University of California at Irvine. Dr. Guinn's testimony was highly technical in nature, but to summarize it briefly, he talked about neutron activation analysis he had done on fragments that were found in the wrist of Governor Connally, among other bullet fragments, and compared these to the bullet that was found on the stretcher in Parkland Hospital on which Governor Connally was lying after the assassination in November of 1963. He said that it is highly probable that Governor Connally's injuries came from the bullet found on the stretcher, and this would tend to support, although not completely confirmed, tend to support the Warren Commission's single bullet theory. He also said that there was no evidence of a third bullet that caused any harm other than the one bullet that the Warren Commission said had injured both President Kennedy and Governor Connally, and then the fatal bullet wound to President Kennedy's head. With us this afternoon are David Lifton, an author who's criticized the Warren Commission, and Jacob Cohen from Brandeis University, who has often defended the Warren Commission. We have very little time left, but Jerry Cohen, what do you say about Professor Guinn's testimony?
Well, I think it's in some very small measure historic. We've been waiting for 14 years for some concrete tie between those fragments and that bullet. The critics of the Warren Commission have been demanding the very tests which he conducted. If ever there was a resolution, if ever it is possible to resolve a question of fact in an area of controversy, one hopes this was it. It's been suggested that the bullet which was found on Governor Connally's stretcher was planted there. Now we must have not only the bullet planted there, but fragments planted in the wrist. I think this is very important and very important confirmation.
David, what do you say about this testimony?
I think it's very important that this tests were done. I think it should be noted that they were done because Dr. John Nichols made Dr. Guinn an expert in Carcano ammunition by getting all these different samples. However, I think it is very important that the House Select Committee have the work double-checked, and not just the spectrography. I'm talking about the statistics and the interpretation, because although spectrography has improved, statistics has not, and this man claims that he sees a pattern in the FBI data that was not seen 10, 14
This is the
years
FBI data,
That's
the
right.
test the FBI conducted.
That's right. He says there's the
ago.
data. There were 2 bullets, but the FBI didn't know it. Statistics hasn't changed. I'd like to see applied mathematicians go into this report and really give it a good type of cross-examination the way an attorney would. And we've had an expert here testifying, and that's what it rides on. And it is important. It's really important that it was done, but it's important that it be done right. And I'll bet you that the House Select Committee will not do that, because they've got a report which supports their conclusions.
Thank you,
right
David.
now.
Gentlemen, we've run out of time. This concludes WETA's live television coverage of the House Assassinations Committee hearings on the death of President John F. Kennedy. The committee has announced plans to continue the hearings throughout the month of September, and National Public Radio will cover them in their entirety. You can listen on many public radio stations. With Jacob Cohen and David Lifton, I'm Sanford Unger in Washington. Good afternoon.
Funding for this program was provided by the Corporation for Public Broadcasting and the Ford Foundation.